All right, so this is problem 1 from the WebAssign, and I made something similar. It's not exactly the same, but similar in spirit. But those questions in problem 1 are just asking you about the difference between probability and inferential statistics. So which of the following are probability questions? So a good diagram to have in your head is the one, there's something in your book similar to this, but when they're probability questions, we're starting with the population and trying to make a statement about a single randomly sampled element from the sample. Similar to I'm going to do in class a coin flip. I know the probability of flipping a head is a half. And I can use that, like if I had 300 coin flips, I can tell you something about if I randomly pulled a sample, what might likely happen. So I'm going in this direction from the population to the sample. So the ones in this checklist that I gave you that end up being probability questions are 1, 2, and 4. 1, in this case, I need to have a definition of, it's easier when you define things. So in 1, X is the number of failures in the sample. And what I'm trying to compute in 1 is I'm trying to compute the expected value of X, which is going to be 300 times P, because I'm going to apply the probability from the population, which is unknown, but in the first, let's suppose that P is equal to the probability of failures for a single randomly selected battery. Then 300 times P is going to be my expected value. We haven't really hit these definitions yet, so it's awkward for me to talk about it. Let's talk about why 2 is also a probability question, but it's posed as a probability question. How likely is it that more than 60 of the 300 batteries will fail? I'm saying if I'm trying to compute the probability that X is bigger than 60. That's what I'm trying to compute. And the last one that's a probability question is the 4th one down. It's almost identical looking to the second one. I'm trying to compute the probability that the number of failures in a sample is going to be 15 above the expected value. I'm posing this as a probability question. It's a probability question. What about the other ones? Let's look at 3 and 5. 3 is not going to be a probability question because I'm asking a question about the population itself, the unknown population failure proportion, which we could use even if P's, that probability is unknown, we use sample data to estimate, we're using something called statistical inference. So for the third one down, that's not going to be a probability question. And the next one, exactly how many batteries in the entire population will fail. It's asking for the realized number of failures in the entire population, not the probability of an event in that sample. That's not going to be posed as a probability question. And so that one also is not going to be a probability question. Let's move to the statistical inference world that's down below. Let's go a little bit further. How do I know which one of these are going to be statistical inference? Well, the statistical inference goes the other way around. In your book, again, there's a little diagram where they have arrows pointing everywhere, but I'm just going to make a little picture. Statistical inference, we take something, and this is usually how we do things. We have a sample, and we infer something about the population. So I'm going in that direction. So in the first set of problems, I have something about the population, and I'm trying to pull that into the sample. In this one, I go from the sample to the population. So if I was going to look at these questions, which ones end up being inferential statistics question? Well, number 1, number 3, and number 5. Number 1 and 5 are almost obvious because 1 and 5 says, does the sample provide evidence, blah, 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 blah. And then the 5 asks, based on the sample, what can we estimate about the failure? It literally asked you, based on the sample, what can you say about the population? So those are obvious. The one that's less obvious, and they talked about this in DeVore just a little bit, they ask you about the confidence, how confident can we be that the proportion of all batteries of this model that fail will lie between 0.10 and 0.18. That is also an inferential statistics question. And the reason it is because the interval concerns the unknown population proportion, and you're using the sample data to confirm that uncertainty. I'm not sure if your actual WebAssign has questions like that, but that is a statistical inference question. How about number 2, the second checkbox? Why is that not one? If we estimate the population proportion rather than claim it must be equal to the sample proportion. That's the reason. Can we conclude exactly 14% of all batteries? Well, we can't do that with the sample. And what proportion of the 300 sample batteries failed during the first year? We already know that is not going to be a inference question. That's just a calculation. Because they gave it to us, right? 42 divided by 300. So that's not a inference question. We're not getting something out of the total population. That's not even a question asked.